Hey guys, this is Coach Lowe, and today we're going to talk about 7.3 inequalities within a triangle. All right, so that should be the title of your page. Make sure you go back to your table of contents and put the page number down that you are on in your notebook. All right, so inequalities within a triangle. We've looked at some with remote interior and exterior angles, and now we're going to move inside the triangle. So Theorem 7.6, and for inequalities within the triangle, we're going to be comparing sides and angles. So let's go ahead and draw a triangle. What's it called when the triangles have all different side lengths? Right, scalene. So we have a scalene triangle ABC. Sides are all different lengths, which means my angles are all different measures. So here's the first theorem. If a triangle All right, so if a triangle has three sides of different lengths, so unequal sides, three unequal sides, then the angles will also be unequal and they'll go in the same order. So let me write this down and then we'll explain it, kind of put it in our own words. If the measures of three sides of a triangle are unequal, then the measures of the angles opposite those sides are unequal in the same order. So let's check out our sides here. So I have side AB, or let's go in order. Side AC is the longest. So AC is bigger than AB, and both of those are bigger than BC. So we had 13 is bigger than 10 is bigger than 8. So we're going to match up those sides that go with those side measures. Now let's talk about angles. The side that's measured 13, the angle that helps form that side is B, because you can see if I extend these lines out where they stop and I go connect those two is the side opposite. So the opening of angle B is the same or matches with the side opposite, which is AC. So if we moved this dotted line in, it would make this side length smaller. It affects this side. So that means angle B is the largest angle. So the measure of angle B is larger than, all right, what's the next side? So side AB is the next side. So the angle opposite AB would be side C. So it's the side that doesn't help form the angle, if you want to think about it that way. So the measure of angle C would be next. And it's bigger than, here's my smallest side. So what angle is it not touching? Well, that would be angle A. So angle A is the smallest angle. All right, so that's the theorem 7.6 that connects the sides to the angles. All right, so let's see if we can list the angles in order from, let's go greatest to least again. Actually, let's go least to greatest because they may ask you that. We've already done a greatest to least, so let's try one least to greatest. All right, so let's say that this is 15 and this is 13 and this is 21. All right, so we are going least to greatest. And let's name this triangle MNO. All right, so the smallest angle, you can go ahead and pause the video. We want to go from smallest angle to largest angle. All right, now that you're back, you should have the measure of angle M is smaller than the measure, so angle M was opposite this one, so there's angle M, is less than, and then we want the next one, so there's side 15 goes with angle O, the measure of angle O, and that is smaller than my last angle. the measure of angle N, and it's opposite the longest side here. All right, got that. Good job. All right, so let's go to Theorem 7.7. All right, if the measures of three angles in a triangle are unequal, then wow, okay, let's try that again. Then the measures of the sides opposite of those angles are unequal, in the same order. So similar to the last theorem that we looked at, but now we're looking at angles. They've given us angles and we want to put the sides in the correct order. All right, so let's get an example rolling here. All right, so 33 degrees and let's see, 56 degrees and 91 degrees. So is that 89, 89, that's 180. All right, got it. All right, so there's my triangle, and let's call this triangle QRS. All right, so smallest angle is here. The side opposite that smallest angle is there. So QR is the smallest. So QR is less than, there's the next angle, 56. So RS. And that is smaller than the longest side, which is opposite the longest angle, QS. I tried to put QR, didn't I? All right, let's try that again, QS. So as we look at these, I circled angle S first because the measure of angle S was smaller than the measure of angle 56, or sorry, the measure of angle Q. Measure of angle S was smaller than the measure of angle Q, which was 56, and it was smaller than the measure of angle R, which was 91. All right, and if you have to list them in the other order, that's fine. You can do greatest to smallest, just use greater than symbols, so going the other direction. All right, the last thing is if we have a right angle, the hypotenuse will always be the longest side. All right, so this is Theorem 7.8. So if we are dealing with a right triangle, the hypotenuse is always the longest side. So let's say this is 3, 4, 5. The hypotenuse will always be the longest side because, why? Remember what we talked about in the section before. These two angles must be acute angles. They have to be smaller than 90 degrees, which makes this angle the largest angle, and the side opposite that angle has to be the longest side. All right, so in a right triangle, the hypotenuse is a side with the greatest measure. All right, so in this case, let's go with ABC. So BC is bigger than AB, and BC is bigger than AC. All right, so I'm glad you guys watched this video, and I will see you in class tomorrow. But here's what I need you to do for me now. I need you to put at the bottom right corner, just put a little star down here, and then high five me when you see me tomorrow. All right, I will talk to you guys later. This is Coach Lowe, and I'm out.